Good afternoon and welcome to our talk on understanding variables for basic statistics. You will be required to provide some detail in your protocol on how you plan to analyze your data. The data analysis plan does not have to be cast in stone at this stage unless you're conducting a clinical trial. It can usually evolve during the analysis phase of your study. However, the analysis planning stage is essential because it makes you think ahead and helps you ensure that your objectives are achievable using the type of data you plan to collect. If you have no statistics training yet, you will need to attend a basic statistics course and have access to basic statistics textbooks and online resources. Once you have some basic competencies, you'll be able to carry out many of the tests yourself. But it is essential that you have your plan checked by a statistician and have them run the more complex tests. Remember that you will need to interpret the results of the statistical analysis in order to write up your results in discussion sections. A statistician can guide you in the process or collaborate with you in the study if your data requires more complex analysis. Before you start planning your data analysis, it is important to be familiar with the key concepts that we're going to describe in this talk. These are the scales of measurement, normal and non-normal distribution, independent or paired groups, and independent or dependent variables. Sometimes researchers have not yet developed an understanding of the language of statistics, and the term a variable can be quite confusing. So let us just explain what a variable is. A variable is something that we note down to either describe the characteristics of a sample or population, or it's something we measure in order to answer our research question. So let's have a look at an example here. If our research question is, how diagnostically accurate is B2M in detecting peripheral arterial disease in patients who have diabetes and various degrees of renal function, we will measure at least the following variables to answer this question: the B2M, the toe blood pressure index, and the estimated glomerular filtration rate. When we describe the participants of our study, we are going to note down the following variables: their sex, age, race, whether it's type 1 or type 2 diabetes. In our clinical studies, much of the demographic data looks like this particular data collection sheet. We'd be looking at age, sex, race, marital status, number of children, employment, level of education, total monthly household income, depending, of course, on what your research is about. What I'd like you to notice here is that some of these variables give you two options, some of them give you more, some of them the options mean something, and in others what's required is a mere number. So we saw the differences in the last slide on what the variables could look like. So we're going to get into key concept 1, the scales of measurement. The type of variable influences the type of statistical analysis that we're going to apply later on in our study. So the first thing we look at when we look at the data is we look at what variables are numerical and which ones are categorical. Now it's easy to remember the difference. Numerical is number. So we're going to be representing things as numbers in numerical data. So things like count of people or a patient's height. Categorical data is you've got categories. You're putting things into boxes. And these things are things like HIV positive or negative, marital status, or severity of disease. So when we go to our data collection sheet, we can see that we've got 3 numerical variables and the rest are actually categorical variables. We are given the categories, male or female, yes or no. For the numbers, we've just got space. We want to know the age in years, we want to know the number of children, and we want to know the number of rands that is earned in that household for that particular month. Numerical variables are again divided into two different kinds. Remember, the numerical variables are the counts, things like the count of the number of people, patient's height, etc. The two different kinds of numerical variables are discrete, and this is where the value can only take on a whole number. For example, the number of patients in a ward. The other one is continuous variable, and here the measurement can take on any value, so it'll take on whole numbers and anything in between. So we've got fractions as well. So in our sheet, we have got two variables that can only be represented in whole numbers, so they are discrete variables. And then total monthly income can be anything. It can be rands and it can be cents. Our categorical variables are also subdivided into different kinds of variables. We've got the binary variables, and binary, like bicycle, means that you've got only two options. It's either HIV positive or HIV negative, dead or alive, smoker or non-smoker. Then we get those categories that are just a name and there is no order to them. For example, marital status, gender or ethnic group. And then lastly, you've got categories, but there's some sort of order in the categories. For example, with severity of disease, we've got mild, moderate or severe disease. In socioeconomic status, there can be categories of annual income as well. So our data collection sheet has all three of these kinds of categorical data. The male and female and yes and no are clearly binary. The race and marital status is nominal, but the level of education from no schooling to attended college or university is definitely ordinal. There is some sort of order in those different categories. So the way we summarize our data is different for categorical and numerical data. When we've got categorical data, we're going to count the number of observations in each category. We'll then calculate the percentage and give us a relative frequency for each category. And if there are several categories, we'll create a bar chart. Always make sure that the numbers in the categories add up to your sample size. So our summary statistics for sex, if we've got 100 people in our sample, we can say 50% were male. It stands to reason the other 50% were female. When it comes to race, in the same sample, we can say 80% were black, 1% were colored, 12% were Indian, and 3% were white. For marital status, we can say 45% were married, etc. For level of education, we will create a bar chart. And as you can see, there are spaces between the bars to show that this is not any data that actually is linked to the next bar. It's always very good practice to create a summary table after you have designed your data collection sheet. This will help you down the road when you're doing your statistical analysis. In fact, I'd like to suggest that you keep this on one of the pages of your Excel sheet to refer to all the time. So in our case, we have age was definitely numerical, discrete. Sex was binary. It could end up being categorical if we added any other options from the LGBTQ or prefer not to answer options. Race was categorical or nominal. Marital status also categorical, nominal. Number of children numerical, discrete. Employment was binary. Level of education was ordinal, and the total household income was again numerical, and it was continuous. It's important to note that the way data is recorded could mean that the same variable might be different in different studies. For example, age could also be categorical ordinal if the data is taken down in age groups rather than in precise age in years. If marital status is represented as yes or no, it will become binary. and total monthly income could be categorical ordinal if the data is requested in the form of income brackets. Another thing to note is I've been to workshops where the word continuous is used in the place of numerical and discrete is used instead of categorical. So how do we summarize numerical data? And here we go on to key concept 2, which is the normal and the non-normal distribution. We look for measures of central tendencies. In a normal distribution, as the one we see at the top here, you can see that we have a bell curve. This is where there is an even distribution of people across a range. Where this does not occur, where we have more people towards the smaller measures or more people towards the larger measures, we get a skewed distribution. If the tail is on the right, then we have a positive skew. If the tail is on the left, it is a negative skew. So we have a non-normal and a normal distribution. In the normal distribution, our mean and the mode and the median all occur at the same point. However, in your non-normal distributions, your mode, median, and mean will occur at different points. And this is very important when we come to look at statistical tests. We also have to look at the way the data is dispersed around the mean. We have to look at the range of the data, which is the amount from the smallest to the largest value. And we look at the interquartile range, which is where 25% occur all the time. And then we look at the standard deviation, which is a calculation that we'll go into just now that shows the amount of variation around the mean squared from the variance. For a good refresher on how to calculate variance, mean, median, mode, standard deviation, etc., please copy and paste this link into your search engine. It's a short video that'll remind you about how to calculate all of these for yourself to do your own descriptive statistics. The symmetry of data can be detected in histograms, such as the one we see here, showing birth weight, or box plots that we see over here. And in this particular diagram, you can see how there is a similarity between the box plot and a curve. To show how we get from a histogram to a normal curve, here we have the histogram, and here we can take the averages of each of those bars and create a frequency polygon, and then you can remove the bars, and there you have your normal curve. As I showed you earlier, the box whisker plot can be seen to be derived from a curve. And these are pretty useful because they can give you quite a bit of information. It gives you your interquartile range, it gives you your median, maximum, minimum, and it also shows you where the outliers are. Very often you can see a graph where there are several box whisker plots. So in this experiment, several people were asked how many hours of sleep they got each night for a week. So on Monday, we saw that people got quite a few number of hours. Friday, they slept very well. Saturday, less so. And on Sunday, it was okay. The night that most people did not get to sleep very well was clearly a Thursday. And there were some outliers. We had some people who overslept on Sunday and Tuesday. And on Thursday, there was somebody who got hardly any sleep at all. Let us move on to key concept number 3, where we're going to be comparing paired or independent groups. And this is where we'll be testing a hypothesis. There's clearly a comparison. If you're going to compare a variable in a single group or between groups, you need to be clear in your procedure in order to select the correct statistical analysis. In a paired group, you will be looking at one group of patients and comparing readings in those patients over time. So you will choose a within participants data analysis design. So one group of patients come in, you take a reading before they get an intervention and then after they get an intervention. You're not comparing them to another group. You're comparing a before and an after. If you're going to be looking at two different groups of participants and taking a single measurement and comparing the groups, you will use a between participants data analysis design. In this case, you're likely to have a control group. If you're looking at two different groups and taking the same repeated measurements, you have to consider within and between study designs. Now let's look at our fourth key concept, the difference between an independent and a dependent variable. And I always find it easiest to explain on this sentence. How cold the Coke is depends on the temperature of the fridge. The dependent variable, the coldness of the Coke, is the outcome. The independent variable, the temperature of the fridge, is the exposure or the risk factor. Confounders are associated with independent variables. And in our Coke example, let's have a look at how long the Coke has been in the fridge, or how warm the Coke was before it was first put into the fridge, as potential confounders. Now that we understand the four essential key concepts, I'm going to provide you with a tool that will help you some way in determining what statistical analyses you will be able to use in your test. This tool will help you think about your approach to stats in your study, but remember that statisticians cannot be replaced. They have entire careers based on looking at the correct stats to answer research questions. What is important with this tool is that you will be able to better understand where your statistician is coming from. Where we're going to be doing a purely descriptive study, where we are not doing any hypothesis testing, and our variable is categorical, we are going to merely present the data in frequencies, relative frequencies, confidence intervals, and bar charts. If our variable is numerical and normally distributed, we'll give the mean, standard deviation, range, confidence interval, error bar chart, or a histogram. However, if the variable is non-normally distributed, then we'll give it the median, the interquartile range, a range, and a box whisker plot. If we're going to be testing our hypothesis, but we are not comparing groups, and if we are not looking at relationships between quantitative variables, then we'll do a cluster analysis or a factor analysis. But if we are looking at relationships between quantitative variables that are normally distributed, we'll look at a Pearson's correlation or linear regressions. If, however, they are non-normally distributed, we would use a Spearman's correlation. If we are testing a hypothesis and are comparing groups, and the groups are paired, and there are two paired groups, and the dependent variable is categorical and binary, we would use a McNemar's chi-square test. If it's an ordinal variable, then we'd use the McNemar-Bowker chi-squared. If, however, the dependent variable is numerical and normally distributed, we'd use a paired t-test. And if it's non-normally distributed, we'd use the Wilcoxon signed ranks test. If we have more than two groups in our hypothesis test and the dependent variable is categorical, then we could use the Poisson regression, a generalized linear model for binomial family, or generalized estimating equation. If the dependent variable is numerical and normally distributed, we'd use repeated measures ANOVA or generalized linear models. And if it's non-normally distributed, a Friedman test or a survival analysis. If we are testing a hypothesis and you're comparing groups and the groups are independent, you will have to list the nature of the variables according to their scales of measurement, as I mentioned we should have done very early on in our protocol, as well as if they are dependent or independent variables. So once we've listed our independent variables, if they're categorical and binary, let's call them 1. Categorical nominal, 2. Numerical normally distributed, 3. And numerical non-normally distributed, we give them the digit 4. If your dependent variable is categorical and binary, let's give it A. If it's nominal, B. If it's numerical and normal, C. Numerical and non-normal, D. And let's see what we're going to do with those. Put them. So let's combine the independent and the dependent variable allocations, and we get everything from 1A through to 4D. And these are the kinds of tests that you would be using. I hope that this talk has given you some confidence in knowing that you can understand statistics, that you are able to have a conversation with a statistician, and that you'll be able to write up your results and discussion with confidence in your statistics. Now you will go and find a beginner's course in statistics, and you will know the difference about when an ANOVA is used, when a t-test is used, when a Spearman's is used, etc. I'm now open for questions. Thank you very much for attending.